My name is Michel Burger. I am the CTO at MIMIK, and I'm here to present a paper we wrote for IEEE called the MEC and MIMIK 1 + 1 = 11. We wrote this paper as the realization that many standards today are stopping at the edge of the network when talking about edge cloud or edge computing. And are not considering that currently devices have become more and more powerful. Today, an iPhone has more computing power than many of the 15-year-old Blade. And also, these devices are more and more power efficient. This paper is a collaboration work between Fer Germany, founder, president, and CEO of MIMIK, Shirva Shalamuti, executive chairman at MIMIK, and EVP R&D at Wells Fargo, and myself. The widespread of knowledge at MIMIK, from core network, device, application, API, and microservices, has allowed us to have a unique approach on how to address the challenge of designing and implementing the solution that cross many boundaries, for example, application and network, and also many industries, like for example, smart home and smart car. And this in an internet of systems that is formed by the hyperconnected world we live in today. To talk about MEC and MIMIK, we first have to characterize the edge. Currently, two complementary approaches can be used to do that. The cloud out approach, where cloud and network providers are putting IT resource, computing and storage closer to where these resources are being consumed. And this includes network elements, on-premise servers, and gateways. And then there is an edge-in approach, where any device that has computing power is not just attached to the network, but an integral part of the cloud infrastructure. This includes actuators, sensors, and user devices like phones and tablets. Combining the cloud out and the edge-in approaches is the only way to form this hybrid edge cloud environment and continuum from central cloud to device in order to address the hyperconnected solutions that are being developed today. MEC is an ETSI standard describing components and interfaces for a cloud-out approach. There are many good papers describing MEC and its usage on the web. MIMIK is an edge-in based platform to allow any devices running an OS from RTOS, Android and iOS to Linux, Windows, and Mac OS to run microservices or expose microservice API and define and maintain clusters by discovery, hence forming ad hoc edge service meshes that are complementary to the cloud service meshes. MIMIK platform is composed of a downloadable edgeEngine and an edge SDK, a set of hybrid edge optimized global function and app domain SaaS, including an identity management based on OAuth 2 and OpenID Connect, and an analytic platform for system and business intelligence. The MIMIK edgeEngine includes a WebAssembly runtime environment compatible with containers, an API gateway to handle serverless microservices, and a sidecar component performing control, routing, monitoring, and security functions for microservice communication. MIMIK platform is cloud neutral, since solutions developed using MIMIK technology can use any cloud provider as a backend system. By bringing the two technology together, MIMIK and MEC, it is possible to develop edge-native solutions where the network acts as a network-aware application-based virtual gateway. Function can run in a cloud-based backend system or can be offloaded to the MEC component at the edge of the network, or can be offloaded in the device themselves And in the case of the devices, the offloading is not happening by creating a client-heavy and monolithic application, but by having a thin client and a set of functions as edge microservices that expose local APIs. Because many edge solutions are based on a collection of devices that need to work together, defining device clusters is key to support edge native environments. However, as opposed to central cloud environments where the clusters of node as generic blade are defined by configuration, in the edge, the clusters have to be defined by discovery, and the nodes are strongly typed since they represent specific item like a user device or a sensor. With Mimic, all of these edge nodes run serverless microservices, and therefore ad hoc service mesh are being defined, and service choreography or local orchestration are being used for local decision making. Combining Mimic and MEC to optimize at the service mesh level, but also at the network level, the communication between the microservices and the connectivity between the nodes is crucial for creating service mesh aware networks, which are key aspects of many edge native solutions. This can be achieved by having Mimic passing the service mesh context to the MEC defined network plane. Beyond the latency and cloud cost reduction that is a consequence of having IT resource at the edge, combining Mimic and MEC to include the device as a prime element for hybrid edge cloud infrastructure is to enable features and behaviors that are not possible to achieve if devices are just attached to the network. For example, instead of having to adapt to the devices and cope with the device diversity in the network element, the normalization can be done at the device themselves, hence reducing the load of the network element and also decreasing the need to upgrade the network element when new devices are being introduced. Processing the raw data can be done in the device itself, and only aggregated data will exit the device, hence handle some of the privacy aspects in a more secure fashion. Making the data actionable at the source allows the data to be used immediately for local decision-making, either within the device or as part of a cluster of devices, instead of just relying on centralized orchestration running in a MEC-enabled component or in the global cloud. The processing activities start earlier. So for example, in case of AI, ML-based recognition, a rough recognition can be done in the device itself before involving a more fine-grained recognition happening in a MEC-enabled IT resource. Having the service mesh context being passed to the network plane is allowing the network not only to be application aware, but more importantly, to be service mesh aware, and therefore capable of triggering self-organized network capabilities or creating network slices to optimize microservice to microservice communication as defined in the network mesh. And then routing operation based on the type or even the semantic of the user data can happen right in the device without compromising the privacy of the user. These are few example of features that are enabled by combining Mimic and MEC together and include the device as part of the hybrid edge cloud infrastructure. I hope that this paper does a good job of showing the need of having a more inclusive approach. So while MEC references are plenty, here are some pointers to Mimic technology. And please don't hesitate to contact us for questions or suggestions for improvement. Thank you.